In this video, we will discuss the use of part parametrization to simplify design iteration. Part parametrization allows the designer to be able to efficiently update the design when needed, without having to make multiple changes each time. Recall from previous videos that CAD geometries are represented using two representations: the topological representation and the physical representation. When it comes to part parametrization, the physical representation changes, and this in turn can affect the topological representation. By definition, part parametrization is when an object or model is governed by a series of values, called global variables, that have the impact to change different aspects, or parameters, of the geometry. Different part parameters will therefore be made into functions of one or more of these global variables. To demonstrate the concept of part parametrization, let us examine a few different 3D shapes, and how their individual sizes can be easily updated. A sphere's shape and measurable dimensions are based on only one-dimensional quantity, the radius, r. As a result, dictating r as a global variable and changing it has direct impacts on the size of the sphere itself. The size of a cylinder, however, is dependent on two changeable quantities, the radius, r, and the height, h. Therefore, the cylinder can be formed as functions of two global variables, r and h. Finally, in the same spirit as the cylinder, a rectangular prism can be represented as a function of multiple dimensions: the length, L, the width, W, and the height, h. Part parametrization is one of those tools that, if applicable, can make designing easy. For example, if the same dimension is repeated over and over, then we can use the same global variable over and over to dictate that dimension. Additionally, part parametrization is useful for situations where part scaling needs to occur. Also, if the same part shape is needed over and over, except in different sizes, then using global variables to define various dimensions can make sure we do not need to just remake a part all anew. Finally, in the case of generative design and optimization, part parametrization ensures easy generation of parts of varying sizes, and iterative optimization. This will become more clear in the design exploration section. This concludes the discussion on the practice of part parametrization. Thank you for watching this video. See you in the next video.